Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Happy New Year to all of our wonderful listeners. Thank you for joining us on this cold January day.
At least we assume it's a cold January day where you are.
It is where
Unless
we
you're in the
are.
Southern Hemisphere, then it's probably warm.
True. Yeah, good point. Good point. Send some of that our way. We need it. Just want to say thank you, like always, to our Patreon subscribers. We really appreciate your support.
For a fraction of the cost of avocado toast, which has gone up a bunch in the last year and it was already expensive, you can hear us talk about more interesting engineering failures.
So that's $5 Canadian a month, and you get twice as much content from us. So that's an engineering failure every week. The mini failure episodes that come out on our Patreon page are a little bit shorter. There's no news, no ads. So we just get right to the point. And these are some of the more simpler or not as in-depth failures that don't quite fit the format of a full-length show, but we still think they're really interesting stories and we want to share them with you. So please check that out. Support our show. We'd love to see you over there. Because it is January and it's a new year, I have prepared my list of goals for 2023. I know I've mentioned this before. I love a list. I love to cross things off the list. It's such a satisfying feeling. And so every year I make a list of different goals that I want to accomplish that year. And then I kind of just work through them. And I don't necessarily get every one. I try to make them realistic because it's really satisfying when I can achieve them. And then it gives me incentive to keep achieving more. But I also try to make them fun. So I'm going to continue to build my engineering firm, going to continue on with freelance writing, hoping to read a bunch of books and hopefully take a few vacations because we all need some R&R.
Unlike Nicole, I don't really do the whole goal setting thing. I used to do that, but then I found that it was, I'd hit about the middle of December or the start of December and realized that I had a list of things I was supposed to do for the last year. And I look at the list, and maybe because it was unrealistic goals, I would kind of conclude that I hadn't really done any of them. So I just stopped making lists of goals for each year. So I just kind of take it as it comes.
The trick is to revisit your goals on a regular basis. So I save my goals in a document that I open all the time. And so I see the goals, they're in front of my face on a regular basis. And so I'm reminded of them, why I put them on my list, and that I need to work to achieve them. And so I'm not necessarily doing large things all the time, but because they're always front of brain, I'm kind of just steering myself in that direction, which I find really helps. But they're not for everybody.
That seems way too stressful for me. If I was going to make a list of goals for 2023, it would be don't make a list of goals. And then I could look at it and be like, yep, nailed that one. Check it off. Done for the year.
Well, aren't you fun? If you have goals for 2023, tell us about them. You can email us at thefailurologypodcast@gmail.com. You can tweet us at failurology. You can reach us on LinkedIn. You can message us on the Patreon page. Lots of ways to get in touch with us. Tell us what your goals are.
With that, we'll move on to this week's engineering news. So this week in engineering news, NASA found a large amount of water in the atmosphere of an exoplanet. So this exoplanet is 700 light years away towards the constellation of Virgo. Scientists using the Hubble and the Spitzer space telescopes, and more recently, the James Webb Space Telescope, which we've talked about on Failurology, they were able to find the remnants of a water, methane, and carbon dioxide exoplanet. So they believe the planet is a gas giant, a quarter of the mass of Jupiter, bigger in radius than Jupiter, and with 3 times as much water as Saturn. Sounds like it's got a lot of things going for it.
Sure does. I think the Hubble and Spitzer space telescopes found the water in 2017, and that was the article that I found first. And then I went to see if they could see it with the James Webb Space Telescope, which is a much stronger telescope. And that's when I found that they were able to also see carbon dioxide. So at first they had likened this exoplanet to Saturn, but now they're referring more to it in comparison with Jupiter, which I thought was interesting. So this exoplanet's name is WASP 39b or WASP 39b, which definitely needs work. Not a great name, but it is what it is. While it is similar in mass to Saturn and similar in size to Jupiter, it's much different than both of those. The planet is believed to rotate around its star once every 4 days. So its year is 4 days long, which is much shorter than our 365. WASP 39b is also 20 times closer to its star than Earth is to our sun, and it's tidally locked, meaning that it always shows the same face to its star, and the planet doesn't rotate around on itself like we do. So we are always showing a different face of Earth to our sun, whereas this one stays in the same position as it moves around. The exoplanet's day side temperature, so the side facing the sun, is about 776 degrees Celsius, which is hot. And strong winds move that heat around to the night side and keep it at a similar temperature, so the entire planet is uninhabitable by humans. It also doesn't have rings or high altitude clouds like Saturn does.
The scientists thought that they would find water on this planet, but as I mentioned, and as Nicole mentioned a little bit, they found much more than what they were expecting on this planet. So with what they found on the planet, that suggests that the planet was formed far away from its star, and it was hit with a lot of icy material. The discovery of water as well, and learning more about how planets form, suggests that formation is much more complicated and much more confusing than previously thought.
If you want to read more about WASP 39b, check out the links on the webpage for this episode at failurology.ca. Hey hun, I'm not sure if you know this or not, but Balls Falls Ostrich Egg Consultants has an exciting business opportunity for an excellent salesperson. Do you ever feel like you don't have enough excitement in your life? Balls Falls Ostrich Egg Consultants has an unlimited time opening on their team where you can make 4 figures a week. The first 3 figures are zeros. Don't put your head in the sand. You can be your own #Bostrich babe.
Now, on to this week's engineering failure, the Algo Centre Mall Collapse. The Algo Centre Mall Collapse occurred on June 23, 2012 at 2:18 p.m. when the rooftop parking deck of the Algo Mall in Elliott Lake, Ontario, Canada collapsed onto 2 floors below, tragically killing 2 women and injuring 19 others.
This isn't the first time we've talked about rooftop parking decks collapsing on this show. If you want to check out episode 23, we also talked about the Burnaby supermarket roof collapse. I want to preface this episode by saying, and this does happen a lot where I go into researching expecting one thing and finding something different. I thought that this was a structural failure. And I mean, to a certain extent it is, but I had expected that a piece of the structure was undersized or some of the connection details were not done properly for the structural components, because that's typically what you see when you're looking at structural collapses. And I'm definitely oversimplifying, but it usually has to do with the design of the structure itself. However, in this case, the collapse is actually due to water infiltration and not having a proper membrane on the rooftop parking deck that allowed water to seep into the building, corrode the structure to the point the structure failed. So had the structure been protected from moisture, it would have probably still been standing, which was not what I was expecting to find, and very, very interesting. And I must say, I'm really excited for this one. I went in a deep dive reading about this well down the rabbit hole. And so we've got some cool information for you today. And I also want to say this is the first building envelope failure I think that we've covered on this show so far, which is really exciting. I love building envelope. It's after mechanical, it's my second favorite discipline of engineering. I find it fascinating. And there are certainly a lot of failures, but this is the first one we've talked about on this show. So this is exciting. I'm excited. Can you feel my excitement, Brian?
I can feel the excitement because you talked about a bunch of the things that I was going to talk about. So I'm going to skip some of those things I was going to talk about, and I'll just mention that Elliott Lake, where this occurred, it's located in northern Ontario, north of Lake Huron, between Sudbury and Sault Ste. Marie, which I believe we've talked about both of those places at various points on this show. So Elliott Lake, it was once known as the uranium capital of the world, but it is now known for affordable retirement living and waterfront cottages. That's probably something I'm going to have to look into in the next couple of years for things. Elliott Lake was not on my radar at this point, but you never know. Now it might be. And it's got a population of around 11,000 people, so not large by any means, but certainly not really small either.
So, as an entry into this collapse, I want to read a paragraph from the Attorney General's inquiry report because it really just sums up the failure well. So, here it goes. Although it was rust that defeated the structure at the Algo Mall, the real story behind the collapse is one of human, not material failure. Many of those whose calling or occupation touched the mall displayed failings. Its designers and builders, its owners, some architects and engineers, as well as the municipal and provincial officials charged with the duty of protecting the public. Some of these failings were minor, some were not. They ranged from apathy, neglect, and indifference through mediocrity, ineptitude, and incompetence to outright greed, obfuscation, and duplicity. Occasional voices of alarm and warning blew by deaf and callous ears. Warning signs went unseen by eyes likely averted for fear of jeopardizing the mall's existence, the social and economic center in Elliott Lake.
Failure of the mall was the result of continued ingress of water and chlorides from the parking deck, which has severely corroded the steel structure for decades. And Nicole touched on this briefly in her introduction a little bit there. So, despite many complaints about the leaking deck and failing ceilings, the owners failed to install an adequate waterproofing membrane on the parking deck surface to mitigate the ingress of water. This problem seemed to be missed by everyone. The owners of the mall, municipal authorities, and structural engineers over the 31 years that the mall operated.
We're getting a bit ahead of ourselves here, and we're definitely going to circle back to talk about the mall construction. But before we do that, let's talk a little bit about building envelope engineering, because as I said, it is my second favorite discipline, if you could have favorites. Sorry, Brian, geomatics is not on the top of my list.
Oh, see, I love geomatics related things. And when you talk about some structural things or building envelope things, that doesn't intrigue me the same way that the positioning and LiDAR and imagery processing things do. But that's one of the cool things about engineering is that there's a whole bunch of different disciplines of engineering and people have different interests, whether it's, car design for mechanical engineering or civil engineering for structure stuff. I feel if you're scientifically or mathematically minded or you just like solving problems, there's probably an engineering discipline out there where you're like, that's really, really neat. And I think that's one of the really cool things about engineering. I get to talk to engineers across many, many different disciplines of engineering. And all the engineers I talk to, they seem to really, really like what they're doing most of the days. And I think that's really cool.
I agree. I think engineering is a fantastic career choice. I will also say a lot of people think that you need to be really good at math to be an engineer, and it certainly helps, but it really does depend on what discipline and what area of specialty you plan on going into. There are different roles and responsibilities that you can go into through the path of engineering that don't require constant use of mathematics. You still need to understand the theory behind it, but maybe you're not doing calculations all day. So back to envelope engineering. So the building envelope is all of the components of the building that separate the inside from the outside. So the exterior walls, the roof, the windows, doors, etc. In the US, they call it building enclosure, but we're in Canada, we call it building envelope. I like building envelope, so we're going to use that term in today's episode. Sorry, not sorry. Envelope engineering is a newer discipline, especially in Alberta. It kind of came to light in the late 90s in places like British Columbia, but more like the 2010s in Alberta. So it's a very new discipline. And as far as I know, there's no formal program for building envelope engineering within Canada, at least not in the same way there is for mechanical, electrical, chemical, and all of the other disciplines that we have. In my experience, most envelope engineers start out in civil and they, quote, accidentally find their way to envelope. Although it's not the only path. Honestly, while I love mechanical, like I said, if I had to choose another discipline, it'd probably be envelope. And The envelope engineers often work really closely with the architect to design systems, strengthen installation details, to control the four barriers, so air, liquid water, heat, and water vapor. And along with that, as mechanical engineers, we work really closely with building envelope because leakage points, envelope performance, and thermal bridging all impact the mechanical system design, our heating capacities, cooling capacities, ventilation, how much infiltration we have. That all factors into how we design the mechanical system. So the envelope and mechanical pieces do work very closely together. And I'm also going to say that thermal bridging is a fascinating rabbit hole that I actually recently went down. But for today, I'll just say that thermal bridging is the path of least resistance for heat loss. So you can insulate a wall all you want, but if there's metal in that wall that passes all the way through it, you're providing a path for heat loss. And so the more you can reduce that path or alleviate it completely, the better your wall will be. If you live in more temperate climates, this may not be as critical to you, but in Alberta, it gets to minus 40 Celsius on a regular basis. So this can be a pretty big deal. Thank you for coming to my Building Envelope TED Talk. Let's get back to the Algo Centre.
So like a lot of small towns, I've lived in a number of fairly small towns in various northern provinces. The mall is not just for shopping, it's a big gathering point. I feel this happens in a lot of, up north small towns and certainly in smaller towns that are away from larger municipal centers. And Algo Centre was not really any different. So Algo Centre housed federal and provincial offices, the library, local members of provincial parliament offices, an 80-room hotel, food courts, and of course, numerous stores where you could do some shopping at. The mall was built in 1979 for a cost of $10 million and included rooftop parking. So from the day it opened, the roof leaked.
Which is what I always look for in a brand new building.
Who doesn't want a leaky building when on day one?
What a nice design feature, an indoor waterfall.
So the mall was a 3-story L-shaped structure, the upper mall level, lower mall level, and pickup level. And then there was a hotel that rose 4 floors above the rooftop parking, plus a mechanical room on top. The structure was a hybrid of steel frame from steel beams and columns and 75 millimeters or 3 inches deep, 1.2 wide or 4 feet wide precast concrete panels arranged side by side to make up the slab. The lengths of the panels, they varied, but were typically around 9 meters. Precast panels were made off-site and had hollow cores to reduce weight.
So the waterproofing issues on the rooftop parking were twofold. Firstly, the rooftop parking area lacked adequate waterproofing to prevent ingress of water to the structure. And we mentioned this. This seems pretty straightforward. The roof leaked. As a cost-saving measure during original construction, the owner decided against a hot rubberized asphalt membrane and chose one that included a non-composite concrete topping. But that topping cracked, and while those were filled with polyurethane and a sealer applied to the entire surface, they didn't hold up very long and the roof leaked from pretty much the day the mall opened. I will say, because of the timing when this building was built, the Ontario Building Code of 1975 didn't clearly outline the waterproofing system that was required, but it did read that, quote, the roof shall be insulated so as to shed or drain water effectively, which it clearly did not. In 1991, options were reviewed to apply a membrane, but were rejected, which takes us to issue number 2. And I gotta admit, I did not see this second issue coming. So this was a interesting surprise. So the second and probably more prominent issue related to the waterproofing was the specified load capacity of the concrete panels and the fact that they exceeded the highest capacity that the panels could handle. So the structural design was such that the engineer of record, they provide a load capacity rating for the floor. And then the floor components are designed by a separate contractor to meet that required capacity that the structural engineer of record outlined. And this process is pretty common in wood frame structures, where the structural engineer provides joist ratings or the floor rating, and then the joist manufacturer designs the entire joist system. The structural engineer for Algo Centre specified 5.7 kPa or 120 pounds per square foot rating, but was told by the panel suppliers that, and this is recorded in the tender minutes for the project, that the panels couldn't support this load and it had to be augmented by a composite concrete topping. And it wasn't just one manufacturer that couldn't do it. From the sounds of it, there were no concrete precast panels that could support this load rating. The engineer said, too bad, figure it out. You have to meet the load without the topping. And then the owner awarded the contract and a system was built and installed that didn't meet the project specifications, which sounds to me like a really large miscommunication. Either the engineer, I think there was a few things going on. The engineer perhaps didn't understand that there were no panels available that could meet it and possibly thought that it was just this one panel and they were trying to save money. The owner obviously didn't understand that by accepting the tender, they were accepting a product that didn't meet the specifications. And then also this was clearly not caught in the shop drawing review process or throughout construction, where there are checks and balances to prevent this type of thing from happening. Published design data from the panel manufacturers note that the slabs were 38% below what they should have been, the specified load. And when this information surfaced in the early 90s, it prevented any engineer from accepting added weight to the slab to accommodate a waterproof membrane or other topping. So because of the shortcomings of the slab's structural capacity, no one would add any weight to it by improving the topping or the membrane. Despite these issues, which clearly facilitated the ingress of water, the panels themselves actually had no part, at least directly, in the collapse. So while the panels prevented the owner from installing a proper membrane on the roof, the panels themselves did not lead to the failure. They were not a component that failed. The failure was in a beam and column detail that the panels were sitting on. So the panels themselves were not a direct part of the collapse, which I also thought was interesting. Of note, despite the concrete panels being under-designed for the specified loads, the steel structure was adequately designed for those loads. So that steel column and beam that did collapse was adequately designed for the load. Unfortunately, the corrosion got the better of it, and that's what led to the collapse. The weird part for me about this entire thing is, why did they keep the rooftop parking open after all of this was discovered? I'm certainly not a structural engineer, but based on some light research, it appears that the 5.7 kPa, or the 120 pounds per square foot, the design specified load for the parking structure, was to account for the vehicles. And so if they took the vehicles off the roof, it was just a regular roof and they just had to account for snow loading. And then therefore that load, that 5.7 kPa, could have been reduced such that a membrane could have been installed. That seems like a good option to me. Maybe I'm missing something, I don't know, but they should have just removed the rooftop parking. I've looked at old pictures. There is a lot of parking elsewhere on the site that could have accommodated vehicles. I think they could have survived without the rooftop parking. That said, I mean, hindsight is 2020. They obviously didn't realize it was going to collapse, whether they should have or not. They clearly didn't know that that was going to happen. And so perhaps they overestimated the strength of the roof and underestimated the corrosion that was occurring inside the mall structure. I don't know. This is really weird to me. I would have just gotten rid of the parking. I don't know. What do you think, Brian?
I think for rooftop parking, it's not like it's a covered rooftop parking from what I understand, or like a heated parking area. And typically in smaller towns, there seems to be ample room for parking, especially, kind of flat, larger parking lots. I know in downtown Calgary and, in other larger municipalities downtown, parking's at a premium. Here in Calgary, I believe parking downtown is about $400 a month, for an underground parking stall. But again, there's so many people that are working downtown and so many buildings and spaces at a premium, so they can charge more. But for a mall in a town of 11,000 people, I just can't see the space demand for parking. So I agree with Nicole on this one that there was probably a better solution of maybe just not allowing people to park on the roof and just making them park somewhere on a ground level parking lot where it could support the vehicle load. Neither here nor there, because this parkade did collapse due to the failing roof membrane, or I guess the lack of a roof membrane. But we're going to talk about that a little bit more here. So the building underwent condition assessments over the years, specifically associated with the sale of the mall. And these assessments occurred in 1999, 2005, and 2009 by 3 different firms. Only the first report outlined the leakage problems, but recommended managing it by sealing the cracks, which seems like a pretty reasonable solution to having these leaks. The second and third reports don't recognize the leaks, or since they don't recognize them, they don't really offer any solutions or mitigations to this problem of leaking.
I will add to that, keep this in mind coming up later. There's something about the third report that we're going to talk about when we get into the aftermath of this collapse that you're going to want to hear about. So just stay tuned for that. But keep in mind that, yes, the third reports that were published don't recognize the leaks or offer solutions.
So the investigations found that the corrosion, which was dependent on leakage rates and de-icing salt, was approximately 0.1 millimeters per year, consistent with marine climates. Despite the level of corrosion being categorized as severe to very severe, in the immediate investigation, it either went relatively unnoticed or was not monitored further to prevent failure. The investigation also found extensive corrosion throughout the mall, with most locations where corrosion was found classified as poor. The top flanges had more severe signs of corrosion than the bottom flanges or the web. The beams are eye-shaped, as in shape of a capital I, with the top and the bottom sections being the flanges and the web being the vertical section. The connections were also badly affected, with more than a third of the connections having severely corroded welds or bolts. Chloride levels from the de-icing salt were also well in excess of the threshold defined for corrosion. So there's a lot of issues going on here with corrosion and structural integrity issues. This is not sounding like a great project, again, with the salt that they're using and what is basically being equated to a marine climate. This is certainly going to have long-term effects like we're seeing in this. So I don't want to say the collapse was inevitable, but I think with all these factors and there not being any mitigation happening either on the membrane side or just in other ways to mitigate corrosion, this is a pretty inevitable thing that the rooftop parking is going to collapse.
I also want to add, having lived in Ontario for the first 2/3 or more of my life, they use a lot of de-icing salt. It is very, very common in Ontario as a way to melt snow on roads and other areas where, well, not even just cars, sidewalks, pathways, parking lots, cars, salt. Just a layer of salt all over the ground. It rots your car, it destroys drains. It's too much. There's too much salt. In Alberta, it's too cold for salt. It doesn't work as well, which I think is a good thing because I don't love all that de-icing salt. So in Alberta, we use gravel, which means we have to replace our windshields on a semi-regular basis. But honestly, I think that's better than rusting out our entire car from the bottom up.
This is true. So if you're looking for a vehicle, maybe try to avoid the ones from Ontario. I think they've changed the de-icing solution, desalting solution they use out there a little bit. But yeah, overall, like Nicole said, Ontario uses a lot of salt. Out here in Alberta, we use a lot of gravel. So the trade-off is that you have to replace your windshield more frequently than if you're from Ontario. Forensic evidence suggests that the failure took place in two stages over several months. The first stage being the failure of the weld, possibly after being subjected to a heavy load of short duration. So this probably wouldn't have broken the connection entirely, but it did shear this a significant amount. So from there, the corrosion continued until the residual capacity depleted even further.
Fun fact, the capacity of that beam joint connection at the time of the collapse was about 13% of the capacity when it was built. 13%.
So it's degraded 87%. Like that's close to 90%. That's not good if your structure degrades 90% of what it should be in terms of strength, or really anything that goes down 90%, generally not good.
No. And it's believed that a small car passing over the joint moments before the collapse was enough to exceed the threshold for shear failure, which was obviously very, very small at only 13%.
So the aftermath of this whole collapse, an urban search and rescue crew arrived at the mall at 2 a.m. Saturday morning, about 12 hours after the collapse, and got straight to work. Rescue work was suspended early Monday morning due to the danger of additional concrete falling on the trapped survivors and rescuers. Late Monday night, the search resumed using heavy equipment to move the unstable escalator structure and part of an external wall. Unfortunately, 2 victims were found 4 days after the collapse. They were believed to be an employee and a customer of a lottery kiosk located under the collapsed roof section. The inquiry into the collapse found that while a customer died instantly, the employee may have survived for up to 39 hours after the collapse and would have been found if not for the suspended rescue operation, which I think is very, very sad.
Both the original structural engineer and architect testified that they did not agree with the decision to make the roof a parking area. And I will say this happens, especially when you're in consulting engineering. The owner is the person making the decisions, but they're also your client. And so you have to definitely walk that fine line between keeping your client happy and doing the right thing for the public. And it's a challenging line to walk. Again, hindsight's 2020. Should they have raised the red flags earlier? Possibly, probably. At the time, did they foresee this collapsing 30 years later? Maybe not. The mall owner's son also admitted that they had pressured engineers to remove information on the roof leaks and the structural steel corrosion from reports, and that they'd faked repair invoices to mislead the bank about the conditions of the building. So remember that third report that I mentioned we'd be circling back to? Well, that third report initially did say that there were issues with water ingress and the structural steel corrosion, but the mall owner convinced that engineer to revise his report and take that out so that they didn't get flagged by the bank, which was a big issue. That engineer, who had declared the building structurally sound a few weeks before the collapse, was indicted with 2 counts of criminal negligence causing death and 1 count of criminal negligence causing bodily harm. Although the trial found that there was not enough evidence to find him guilty beyond a reasonable doubt. So he was aware that the roof was at risk of caving in, but like I said, he altered his report so that they didn't jeopardize the building's refinancing. His license was also suspended at the time when he performed that inspection, so he really had no business performing that inspection in the first place. But luckily for society, he lost his license completely following the collapse because of whatever he had done to get his license suspended in the first place and the fact that he doctored his report. As we talked about on the episode 65, when the OIQ lost their ability to self-regulate, the main mandate, the rule number 1, our first and foremost goal as an engineer is to protect the public. And this engineer clearly did not act with the public's interest in mind. So it's not surprising that he lost his license, and it looks like Ontario was doing a great job of regulating and investigating their members. The inquiry also heard that the rooftop parking area was often used to bypass a set of traffic lights in town, which added to the traffic and stress planned on the structure. So the mall was kind of located on a corner, and there were 2 ramps onto the rooftop parking area, so people would go up one side and down the other to bypass this light. And that just added a lot more traffic onto the roof. The mall was demolished in 2013, and a new mall was built without a rooftop parking area in its place. It opened in the spring of 2016, and with the mall being such a large part of the town's economy and access to essentials, its collapse and closure had a big impact on residents. Because Sudbury and Sault Ste. Marie, the closest cities to Elliott Lake, were about 100 kilometers away each, it was quite challenging for them to get access to a lot of goods and services that they would have gone to the mall to access. A temporary grocery store opened in October 2012 to replace the one that had been in the Algo Centre Mall, and its replacement, the new grocery store, was the first store to open in the replacement mall.
So there you have it, the Algo Centre Mall Collapse. A poorly located rooftop parking lot with an inadequate waterproofing system led to decades of corrosion and the ultimate collapse of the mall roof.
For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find us. If you want to chat with us, our Twitter handle is @Failurology. You can email us at thefailurologypodcast@gmail.com. You can connect with us on LinkedIn, or you can message us on our Patreon page. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode where we'll talk about the Sayano-Shushenskaya hydroelectric power plant accident caused by catastrophic failure of one of the plant's turbines. I'm going to practice how to say that name a lot of times before that next episode. Bye everyone. Talk soon.